Welcome, my dear student, in our math program for secondary 3. Dear student, now we are taking general revision determinants. Look at the first example. Without expand, prove that determinant contains first row 0KL, negative K 0M, negative L, negative M 0 equals 0. Look at K, L, M are any values. Solution. Taking negative 1 has a common factor from R1, R2 and R3. Then determinant becomes negative 1 multiply determinant contains first row 0 negative K negative L, K 0 negative M, L M 0. Change row and column by taking negative 1. Look at, dear student, determinant becomes 0 KL first row, negative K 0 M, negative L negative M 0 equals, look at D equals negative 1 times D. What you mean? D equals, yes, 2D equals 0 because D equals negative 2D. 1D plus 2D, 1D plus 1D equals 2D. 2D equals 0. Therefore, determine equals 0. This is the required. Another example. Prove that. Look at determinant. To determinant 4, negative 1, 6, negative 7, 3, negative 9, 2, 0, 1 plus another determinant 4, negative 1, negative 3, negative 7 plus 3, 5, 2, 0, 8. What did you use? Look at the third determinant, negative 1, 1, 6, negative 7, 3, negative 4, 2, 0, 9. Dear student, look at the first determinant, second determinant. First row 4, negative 7, 2, negative 1, 3, 0. First and second determinant. Prove that sum of 3 determinants equals 0. Remember, dear student, C1, C2 are identical in D1, D2. What you deduce? Yes, D1 plus D2 equals D. By adding the third column in D1 and D2 equals 4, negative 1, negative 3 plus 6, negative 7, 3, negative 9 plus 5, 2, 0, 1 plus 8 equals what? 4, negative 1, 3 and negative 7, 3, negative 4, 2, 0, 9. Look at R1 and R2 are identical in D and D3. What you deduce? Look at the first row becomes 4, negative 2, negative 1 plus 1, 3 plus 6. Second row, negative 7, 3, negative 4, 2, 0, 9. Look at the first row, third row are same elements. As example, look at 2, 0, 9, first row, third row, 2, 0, 9. 2 rows are equal, all elements are same, then determinant is equal 0 without expansion. Then determinant equals 0. Why? Since R1 equals R3. Dear student, therefore D1 plus D2 equals D. Therefore, look at 4, negative 2 minus 1 or negative 1, negative 3 plus 6. We divided 2 determinant is the first determinant. Look at another example. Without expansion of the determinant, find the value of determinant contains first row 13, 16, 19, 14, 17, 20, 15, 18, 21. Remember, without expansion, we find the value of this determinant. Solution. Look at, we add R1 plus negative 1 multiply R1. We add R2 plus negative 1 multiply R1. R3 plus negative 1 multiply R2. Look at determinant becomes first row is the same 3, 16, 19, but second row, third row change 14 minus 13, 14 minus 13, 20 minus 19, third row becomes 15 minus 14, 18 minus 17, 21 minus 20. After that, determinant becomes first row 13, 16, 19, 1, 1, 1. Second row, third row, 1, 1, 1. Two rows are equals, then determinant equals 0. Because R1, R2 equals R3. Because R2 equals R3. 1, 1, 1, first or second row, second row. Third row, 1, 1, 1. All elements in second row, third row are same, then determinant equals 0. Another example. Look at determinant 3, negative 1, 0, 0, 2, 4, negative 2, 3, negative 2. Use the element of the first and second, first factor, cofactor of the second row. Look at 3 multiply determinant, square determinant, negative 1, 0, 3, negative 5, plus 1, multiply square determinant 3, 0, negative 2, negative 5, plus 3, multiply determinant 3, negative 1, negative 2, 3, equals what? 3 times 5 minus 0, 1 times 15 minus 0 plus 0, answer is 15 minus 15 is equal 0. We are translate to another example. If we have D3 equals determinant, look at determinant D3 1, 0, 0, 2, 4, 0, 5, 3, 0. Look at 0 triangle. The value of this determinant multiplied by mean diagonals 1 times 4 times 6 equals what? Equals 24. When we find determinant has 0 diagonal, has 0 triangle, 0 triangle up or down, we find the value of multiply by elements of mean diagonal 1 times 4 times 6 equals 24. Also we have another one. Look at determinant 0 diagonals. The value is multiply all elements of mean diagonal 4 times 2 times 6 equals what? 48. Translate to another example. Without expansion, prove that determinant contains 48, 55, 58 first row, 79, 19, 83 second row, third row 12, 19, 22, plus determinant contains first row 48, 55, 58, 12, 19, 22, 43, negative 24, 37 equals 0. Dear student, look at the first row in the first determinant and second row. 48, 55, 58 in the first row in first determinant and first row in the second determinant. Look at the solution. By change R2 and R3 in the second determinant, we replace determinant becomes we change. Why we change? By taking negative 1 highest common factor. Answer is the second row becomes 48, first row 48, 55, 58, but second row becomes 79 minus 43, 19 plus 24, 83 plus 43, third row 12, 19, 22. Since R1, R3, look at R1 and R3 are common, has common, therefore determine R1 minus R2 and R2 minus R3 becomes the first row 12, 12, 12, second row 12, 24, 19, third row 12, 24, 22. Look at, dear student, answer is 2 by highest common factor multiply first row 12, 12, 12, second row 12 times 12, 12 times 12, 12, 12, but third row 12, 19, 22. Therefore, R1, R3 are identical. What is use 2 times 0 equals 0. Now we are translate to another example. Without expansion, determine. Look at determinant A, first row, A minus C, 2A. B, A minus C, 2B. C, A, B plus C equals A minus B inside bracket times A minus C times bracket contains B minus C. Remember, dear student, we can prove that determinant equal bracket contains A minus B multiply another bracket A minus C bracket B minus C. Look at the solution. Left hand side, look at, we multiply C1 by 2, then subtract from C3. We multiply the first row, first column by 2. After that, subtract from C3. First row, first column, A, B, C. A, B, C. We times first column by 2, then subtract from C3, column 3. 2A times 2A minus 2A equals 0 in third column. 2B minus 2B equals 0 in third column. We multiply 2C, after that subtract B plus C minus 2C. Answer is B minus C. What is the position in third? C3, 3. B minus C. Look at the third column becomes 0, 0, B minus C. After that, we subtract second row from first row. Look at, dear student, determinant becomes first row A minus C 0, 0. Second row B A minus C 0. Third row C A B minus C. Look at the triangle or zero triangle. What is the value of determinant? We multiply the mean diagonal. Therefore, A minus B multiply A minus C multiply B minus C. Right hand side. Look at another example. Using properties of determinant to prove that determinant contains B minus D, B minus C, C first row, B minus D, C, B minus C, second row, negative D, B minus C, B plus C, third row equals 2 multiply bracket contains 2B minus D multiply bracket contains 2C minus B. Look at the solution. We add C1 plus C2 plus C3. Look at, we add C1 plus C2 plus C3. Determinant becomes 2b minus d, first column, 2b minus d. After that, we have common factor 2b minus d. Answer is 2b minus d multiply. Determinant, first column is 1, 1, 1. B minus C, C, B minus C, second column. Third column becomes C by B minus C, B plus C. Therefore, R2 minus R1. After R3 minus R1, 2b minus d multiply, bracket determinant. Look at the determinant. First row, 1b minus c, c, 0, 2c minus b, b minus 2c, second column, second row, third row, 0, 0, b. Look at x and student, 0 triangle. After that, we find the value of determinant by multiply mean of diagonals, element of mean diagonal 1, 2cb, 2c minus b, multiply b. After that, answer is, yes, 2b minus d multiply 2c minus b, equal right hand side. Now we are translate to another example. X minus 2 is a factor of determinant. Determine first row, x minus 1, x plus 3, 2, negative 3, x plus 5, negative 6, x plus 3, 2, x plus k. Find the value of k. Look at the solution. What do you mean, dear student, x minus 2 is a factor? Means factor determinant equals 0, x equals 0 by substitution about x equals 0. Therefore, determinant equals 0. C2 minus 5C1, we multiply C1 by 5, then subtract from C2. After that, we times or multiply C1 by 2, then subtract from C3. Determinant becomes 1, 0, 0. Look at second row, negative 3, 22, 0. Third row, 5, negative 23, k minus 8 equals what? Equals 0. Look at the 0 triangle. We find the value of k by using multiply all elements in mean diagonal. 1 times 22 times k minus 8 equals 0. Then 1 times 22 times k minus 8 equals 0. K minus 8 equals 0. What you deduce? K equals 8. The value of k equals 8. Now we are translate to another example. Without expansion, prove that determinant. Look at the determinant. First row 1 plus 2x, 2x minus 1, negative 1. Second row 5 plus 7x, 7x negative 5, 0. Third row 3 plus 4x, 4x minus 3, 0 equals 2x. Remember, dear student, we have determinant has 3 rows, 3 columns. Prove that without expansion, this value of the determinant equals 2x. Multiply determinant 1, 2, negative 1, 5, 7, 0, 3, 4, and 6. Look at the solution. We add C1 plus negative 1 plus C3. Answer is determinant 2, 2x minus 1, 10, 7x minus 5, 0, 6, 4x minus 3, 6. Therefore, answer is 2. First column 1, 5, 3, 2x minus 1, 7x minus 5, 4x minus 3, negative 1, 0, 0 equals. After that, we add C1 plus C2. Look at when we add C1 plus C2, determinant becomes what? Yes, 2 multiply determinant 1, 2x negative 1, 5, 7x 0, 3, 4x 6 equals 2x. Look at 2x. We have x common factor from the second column. Answer is 153 in first column, 274 in second column, negative 106 in third column. Then the determinant becomes 2x multiply determinant 153, 274, negative 106. Another example. Using Cramer method to find solution set of the following equations: x plus 2y plus z equal 3, 4x minus y minus z equals 6, also x plus y plus 3z equals 10. The value of x, y, z, which satisfies all three equations by using Cramer method. Look at the solution. As the first, find the value of delta, coefficient of x, y, and z. Coefficient of x 1, 4, 1, first column. Coefficient of y 2, negative 1, 1. Coefficient of z 1, negative 1, 3. Then by using all methods, one of all methods to find the value of determinant, first row, first diagonal, first column, delta equals negative 23. After that, find delta x by exchange column 1 by 2, 6, 10. After that, find the value of delta x by one of the determinant solution equals negative 46. Delta x equals negative 46. After that, delta y equals exchange the second column by 3, 6, 10. After that, find the value of delta y equals 23. Delta z by the same method, change the third column by element 3, 6, 10. After that, find the value of delta z by one of the all methods. Then delta z equals negative 69. What is the value of x? Delta x over delta. What is the delta x? Negative 46. What is the delta? Negative 23. Then x equals 2. Y equals delta y over delta. What is the value of delta y? 23. The value of delta negative 23. Answer is negative 1. Z delta z over delta. What is the value of delta z? Negative 69. The value of delta negative 23. Then z equals 3. Remember, value of x2, value of y negative 1, value of z 3. Then solution set is 2, negative 1, 3, 2 represent x, negative 1 represent y, z represent 3. Now we are translate to another example. Using Cramer method to find solution set of following system of equations: x negative 2y plus 2z equals 1, 3x plus 4z equals 8, and 6z minus 2 minus y equals 2. Remember, we form delta by putting coefficient of x, y, and z. Look at delta. Delta is 1, negative 2, 2, 3, 0, 4, 0, negative 1, 6, equals 1, 3, 0, 0, 6, negative 1, 0, negative 2. By adding the second, third column, answer is equals 34, not equal 0. Delta x, by change the first column by 182, answer is 182 first column, 0, 16, 3, second, 0, negative 12, 2. Answer is 1 times 34 times 2 by using properties equal 68. Delta y equals determinant first row 1, 1, 2, second 3, 8, 4, 0, 2, 6. Change the second column by 1, 8, 2. Look at the first row 1, 1, 2 by using first column 1 multiply 48 minus 8, negative 1 multiply 18 minus 0 plus 2 multiply 6 minus 0. Answer is 34. Therefore, delta y equals 34. Delta z equals change the third column by 182, coefficient of z. Then delta z equals 1 times 0 plus 8 by using the first column, negative 3 times 4 plus 1. Answer is 8 plus 9 equals 17. Then delta z equals 17. What is the value of x? Delta x over delta. What is the value of delta x? 68. But delta equals 34, then x equals 2. What is the value of y? Delta y over delta. The value of y, 34 over 34 equals 1. Also, z, delta z over delta, delta z equals 17 over 34 equals 1 over 2. Then the relation or the values of x and y and z, solution set of x, y, z, 2, 1 and 1 over 2. 2 represent x, 1 represent y, 1 over 2 represent z. I am very happy to spend such time with you. Goodbye.